If you look in not the last page, the last I'm going to copy and paste this page, okay? So if you look at, okay, these are materials now, okay? If you look at this material over here, and let's go for PSI. No, let's go for standard stuff like this, okay? And I'm going to take a snapshot. We're going to look at this. Okay, and I'm going to show you progressively what is going on, okay? So you see a material handbook, and what you see, okay, is, let's focus on use strength for now. Okay, let's focus on use strength for now. Okay, let's focus on use strength for now. So they mentioned that the use strength in tension is what? 250. Okay. So the test they did, right, is exactly the same test that we are going to do with our chalk. We are going to stretch the chalk out. Okay. Now, before we get into here, we know that there's a construction, what we call as a stress strain curve. You know a stress, oh, heard about it? You should have heard about this in 303, yes or no? Okay, so we have a stress strain curve. Okay. So this is our strain. This is our stress. We stretch this out. We have a dip, and then we have this. Okay. So we know that this is your what? Ultimate what? Strength. And we understand that this is your what? Use strength. And we get the point that this is your what? This is your fracture. Now, because that we are dealing with chalk, okay, for brittle material, it looks like this. And then it go boom. Okay, so this is for what? Brittle what? Material. Now, how is this related to your what? To your Mohr circle. Okay. So now I'm going to draw my Mohr circle. Okay. And I'm going to deliberately, no, I don't make it complicated first. Okay. So this is known as your normal stress. This is known as your shear stress. Element rotate clockwise, element rotate anti-clockwise. I'm now going to draw a box. Okay, so we have this box then. This box represent 2, 4, 6, 2, 4, 6, 6. Okay, so this box represent, okay, 1, 2. So this box represent over here, this is your stress yield. Okay, this is also your minus stress yield, and this is your maximum shear line, and this is your minus maximum shear line. Okay, so now I'll give you a stress function now that we are pulling the structure. Okay, so when we pull the structure, we have now another graph over here. And this is time, and this is your force. and then we start pulling. Okay. And this is your time 1, T1. Over here is your T2. And then over here is your T3. Okay. When we are at our T1, the Mohr circle looks like this. This circle is at T1. Okay. Before I go into the circle, if we were to construct Mohr circle on this, on the chalk, okay, same chalk that you see on the center, we are reducing stress X, okay, normal stress as a function of what? Time. Okay, normal stress. So now when we go into T2, okay, when we go into T2, so before I go on, we know that over here, this is our point X, and this is our point Y. What you realize is our point Y is always anchored to zero stress because we are doing a uniaxial tensile test. Now, when time goes further, your forces go higher. So what you realize now is your what? Your circle grows what? In fact, I do apologize. Can you all string this down, please? Okay. It should not be the same. I do apologize. Okay. So this is your. Okay. Or I make it slightly bigger, just slightly. Okay. It should not be equal. Okay. I drew it equal, which is not realistic. Two, four, six, seven. My eyes is really F. Go on. Yeah, Eugene. Come on. Two, four. Okay. Okay. So again, still the same. So the next time when T is equal to 2, your stresses get what? Your stresses get bigger. Okay. Your stresses get what? Get bigger now. Can you see that? Okay. So this is occurring when now this is equal to time is equal to 2. And then when time is equal to 3, okay, when time is equal to 3 now, so for example, when time is equal to 3, we have this trend. Okay. So over here, this is our point X, and our point X keep on growing. Okay. Our point X keep on growing. Okay. Now, when our point X touches the yield, for this case, okay, we are focusing on a brittle material. So now, this surface is known as our what? Our X, and this surface over here is our what? Our Y. Yes or no? I taught you how to draw surface X and surface what? Y. So now when I pull to fracture, what happened? The fracture will occur on surface X or surface Y. Which one? X. Yes or no? So when I pull, right, it occurs this side. Okay, if I put the element here now, right, we realize that this surface over here, right, is also equal to what? This surface over here. So what I'm trying to tell you now, over here is also our what? surface fracture orientation. Later on, probably on Friday, I will buy 300 plots. Everyone. We are going to test this hypothesis to see if it's true. Ladies and gentlemen, you have to visualize Mohr circle. If not, this is the base of what? Of analysis. So now, coming back to the materials handbook now. Okay, coming back to materials handbook now. What you see over here, all these values are our what? All these values are our principal stresses. Are we clear? Because you will be asked to define what stress when you measure what they are. No. What is it? It's your what? Principal stress. Students graduating from this program, they have to know. Students graduating from other university, they don't need to learn. I don't give a shit. You all have to what? You have to know. Are we clear? Okay, because at the end of the day, you have to use what? That data over there to design your what? This is what mechanical engineering is all about. And why it's even worse, we design structure that move. Okay. Now, from here on, you can see what is going on with our what? With our normal stresses. Okay. The next thing that I'd like to emphasize, okay, is the normal stress is equal to Px over A plus or minus moment about Y over Iyy multiplied by Z plus minus Mz over Izz multiplied by Y. Okay. Now, I teach Mohr circle first because I want you to know what Mohr circle means. Because that equation that you see over there, you've seen it before? Oh, it's straightforward. Okay. So over here, this is induced by axial load. And this is caused by a what? Bending moment. Okay. We are doing real design work now. Okay. We are not doing Mickey Mouse stuff now. Are we clear? Okay. So that is your normal stress. So once you find out what is your normal stress, then you can construct what? Mohr circle. All right. The next thing that we want to look at is we are going to look at shearing stress. Okay. Sorry, too fast. Maybe some of you need to be armed with tranquilizer. If I get too excited, just shoot me, okay? Are you all excited or you're like, whatever? No excitement yet. Now, you know what's very interesting? How many of you are in the bio? It's interesting is this. I was asked to be in a committee in how our human body functions, right? Now, if our body is straight, when we do a compression load, our backbone is under what sort of load? One type of load. So that's what? Normal stress. Axial load on our spine. Now, if you were to tilt your head and then we put a normal load, what stress is it? Eccentric buckling. Eccentric buckling. That is why when you are carrying a load on your head, a heavy load, make sure your back posture is what? Straight. And you walk. Yes or no? If you happen to bend, what happened? More stresses is acting on your what? On your back. Are we clear? Okay. Again, back to the theme of what? I'm crazy about this. What am I crazy about? What does this mean? Any idea? Fundamental. Fundamental, the fun make you go crazy. Are we clear? Okay, relating to what you learn based on the foundation, relating to the real world, big difference. Okay, now, next thing that we are going to look at shearing stress. Okay, so shearing stress are stresses acting parallel to the surface. Okay, are acting what? Parallel to the surface. Unfortunately, we have to go back to the element again. Okay, so this is your what? This is X, and this is Y. Okay, then I'm going to draw on one side, we have what we know as positive shear.